Okay, in this video I'm going to go through the basic settings for the Interface PNP to get it going. First thing we'll do is open Tool, go to File. You'll probably need to create a new project. Click on that and open up a new project. This I will set as PNP test. We'll click Other, go to where our INI file is saved. You'll know it because it ends in .ini. Click Next. We'll click our sensor, our wideband that we're using. The units with the built-in wideband use the NPLX 0 to 5 scale. If you're using an external wideband, then it's most likely a list. The other setting you need to set is activated for microsquirt module. My test unit's MS2, so I'll just leave it set to that. My computer uses COM6 as the COM port. If you're using a different COM port, you need to select it list. Once it's done, you can click Test Port, and it should say successful here. Once you're done with that, pick out the dash you want. You can click the drop down here, and there's some different dashes in there that you can choose from, but we'll just use this one for the test project. Once you're done, you can go up and click on Basic Setup and go to Engine Constants. This is where we set our required fuel. Be sure to set to CC, put in the CC of the engine, number of cylinders, the size of injectors, and the air-fuel ratio. Most stock Hayabusas have a 24-pound injector. Of course, if you have different sizes, you can put that in there and it'll change this number. Basically, this is the amount of fuel that motor should use with that size of injector at that air-fuel ratio at 100% volumetric efficiency. If you need to add or subtract a certain amount of fuel globally through the whole controller, say all of your startup enrichments, warm-up enrichments, fuel table, everything by 10% or 15% or whatever, you can pull it out or add it by this number here if you want. If your fuel table doesn't have enough range, and if you're running out of range in your fuel, then you can adjust this number to compensate. But initially you can set it up to whatever the calculator gives you. It should get you very close. Once it's tuned, if you change injectors, you can go in here and use the calculator again to size the injectors and the required fuel. Should get you fairly close to where you need to be. You're going to have to retune it, of course, but it'll get you really close, or get you fairly close. That's pretty much it for that. The other neat feature about almost all of the menus have this little pencil with a quotation mark. In here you can put little notes to yourself on specific settings, and you'll see that each one has one by it. But each one of these settings you can put a little note to yourself for specific tunes for a specific setting. So you've put a setting in there, you can put a note to yourself why it's that number or why it's that specific setting for each tune or each specific bike or whatever. Once you save an MSQ, which you go up to File, click Save Tune As, name it, save it. It saves all of your little notes in. So you can make a little note for this tune, and you can hook up to a different bike, tune it, have a note in there for that tune, and each tune will save each one of the notes that you've saved, or any of the notes that you saved. You can have a note for every one of these different settings throughout all of them on here for each specific. Like we go trigger wheel settings, you can have a note here. You can put a note 24-1 for this specific bike, 24-2 for this specific bike, whatever. And it's pretty nice to have that to kind of remind yourself why you have something a certain way. And it saves it for each specific tune. So it's a nice little feature. That's one of the things you need to go and set also is your crank trigger wheel. Most of the Hayabusas are 24-1. 100-degree offset for all of them, no matter what they are. Some of the GSXR 1000s are 24-1. Some of them are 12-1. Some of the early Busas with the 16 ECUs had a 8 tooth wheel with no missing teeth. For those particular bikes, they have to be set up for coil plug. Every box I send out is set up as wasted spark unless it's specifically asked to be coil and plug. For those, you have to have a missing tooth wheel to run wasted spark. So it has to be 24-1 or 12-1 or something like that, depending on if it's a Hayabusa or GSXR. Pretty much all the boxes I sent out, I set up as 24-1 because that's the most common crank wheels that's on them. If your bike has something different, then that needs to be discussed when we order it and should be set up as that. But you really need to check this initially when you go through the setup menus before you try to start the bike. Make sure all this stuff is correctly. I'll set it back to 4 for my test unit here. Any of the scenes that have red beside them have to be power cycle. In other words, you'll put the setting in, the number in, hit burn, turn the key off, turn it back on, and it should have the setting there then. Once you're done, you can hit close. The main fuel table is here, fuel VE table 1. Fuel VE table 2 is PS table. I set all up to have blended in. In other words, it uses both tables. The scale on the main fuel VE table 1 is MAP and KPA. In other words, 100% KPA is basically anything over 100 is basically pressure. This would be actually aspirated table because it ends at 105. Starts at 20 KPA. Boosted application, of course, it would go way higher. It would go, depending on the boost level, all the way up to 400 KPA. The bottom is your scale, of course, and the numbers are in the VE table RV. You can use these scales to whatever. You can spread them out, whatever. Punch a number and it changes it. Same way with the PS table. This is throttle position angle on this side, RPM on the bottom. What makes it nice about having dual tables is with the throttle position table, say you have a rich spot or lean spot at a specific throttle angle that you can't get out in the map, you can go right to the PS table and either richen it up or lean it out in that specific spot. And it also makes your throttle position or your throttle response really good having the dual tables. You can fine-tune it way better than you could strictly on speed density or map based. So everybody run the in with the independent throttle bodies. The initial tables that come in, they should be really close to get it started if you've got your required fuel set correctly. And that's it for the fuel tables. Rev limiter, be sure this is set to the appropriate rev limit for your motor. I send pretty much all of them out with spark retard and cut. The spark retard number is the amount of degrees it pulls out. So right now it's set at 28 degrees. If at 10.8 it's set at 28.1, it will pull 10 degrees, so it'll be at 18.1. And then at 11,000 it'll go into a spark cut. You can select the style of cut, spark retard, which I wouldn't really recommend because it will actually go through the rev limiter. It'll just retard the timing, that's it. You can have a fuel cut. You can have a spark retard and fuel cut. Spark retard and cut, which is the only style that I'd recommend for a boosted application, or a fuel and spark cut. Any of the 4 here you can use for naturally, or I would recommend for naturally aspirated, but only this one I would recommend for a boosted application. So be sure to check this menu and make sure that it's set appropriately for your motor, because this needs to be set correctly so you don't blow it up. The other thing that is, well, the initial tables that come in the controller should be really close to get the bike started and may even be spot on. You may never touch them again. But if you need to, these are the main tables you need to set for priming and crank and your warm-up, Richmond, to make sure the bike starts cleanly and sets and runs without dying or kicking back or any problem starting it. This is the most overlooked portion of a standalone as far as tuning. If you ever had a standalone where it took you forever to get it started, or was really hard to start or something, more likely this is why it doesn't start cleanly or idle cleanly whenever it's initially starting up. Pulse width is the amount of fuel when it initially we turn the key on. It injects a small amount of fuel in. sort of like an accelerator pump on a carburetor, where you'll pump it once before you turn the key on. You can click and drag that specific point on wherever you want, or you can go over to the window and actually punch in a number. And here you can change the coolant temperature for that dot and the priming pulse width number. Pulse width, this is the amount of fuel that it adds while you're cranking it. If you have a hard time getting it to start cranking, you can either go up or down in that specific region and get it work quickly when you initially hit key. On my bike, I've got it set now. My bike can set for 2 months, and I can hit the key, and within 3 revolutions, it's fired up and idling. And that's how it should be. You shouldn't have to crank on it for 30 seconds to get it started. It should start real quick. So if you do have problems with it, you'll need to come in here and adjust the table. Like I said, the initial table would be something that's real exotic, really huge injectors, cams, just something that's not the typical setup. You may have to come in here and adjust them. After start percentage is basically what it is it's an additional amount of fuel that it adds over a period of time when it first starts. So for so many ignition revolutions or percentage of time, it'll add so much fuel and slowly taper off and go straight to the warm-up enrichment. This table you'll probably own. More than likely you won't have to adjust it. It's there if you do have to. That's the percentage table of fuel that it adds, and this is the taper time, the amount of time that it tapers off. Warm-up enrichment, this is basically like a choke. These numbers are fairly close, but if you do adjust them, I'll walk through the idea of them. Basically, at 60 degrees, this table will add 25%. You ignore the 100 and just look at the two numbers. So it'll add 25% to it. 83 degrees, it'll add 14%, and so on until it ends at 100. 100% means at 124 to 160 degrees and on above that, it will use 100% of the VE tables. If it was at 90, it would only be using 90% of the tables for your main fueling. If it was at 0, you'd have no shot to temperature. The pulse width would actually drop to 0. So it would inject no fuel to the motor at all. So be sure that whatever you end your warm-up enrichment curve to, it ends at 100. Once you're done, you can hit burn, and that's pretty much it. That's pretty much it for this video. This is just a quick start to get you going. This should get it going really quickly. If it doesn't, then there's troubleshooting that you'll need to go through to determine what's going on. If you're not getting RPM signal, of course it's not going to run. So if you're cranking it over and you see no engine speed showing, then you have problems right there. If you're getting engine speed and it still isn't started, then there's some other troubleshooting things you need to go through to get it started. But this should get just about any bike started. Every bike that we set up so far, all the way from stock natural gas spray away to alcohol injected huge inch motors, have started within 5 minutes of setting them up. So it should be really easy and quickly and painfully easy to set up. Keep watching for my other videos, and thanks for watching.